All right, it is Monday,
November 20th.
November 20th. We're in module 2, and we're talking about what?
Healthcare facility.
Healthcare facilities.
Emergency care.
I'm gonna pull up, we're gonna go over what, in section 2, what does it say our heading is? What are we gonna go over tonight?
Devices used.
Devices. What is a device?
Receptacle.
Receptacle. Yeah. All right. So we're gonna go over that tonight. That's what we'll cover. We got a homework sheet that we'll go over. I asked you to read section 2, right? So we'll go over that. We'll go over a few code items that pertain to that. And we're going to go over section 2 homework section first. So we'll do that. And then that'll be about it for tonight. Let me get the computer up to snuff here so we can get started. Get us online here and find this thing. How did I find it last week? I don't remember. How did I find it? That ain't it. Here we Well, I know it's on here, because I saw it earlier today. Internet's messed up. That's not the one. Here we go. Go. Module 2, section 2, that was for homework, right? Find mine. Go over each one of these. That's the plan there, so I know what we're going to do. Let's talk a little safety first. Let's see what my safety topic was going to be for the night. Job site safety concerns on current job sites. So, any issues? Anything specific as far as your job site is concerned? Anything special? What kind of safety you got going on your job site?
Just watching out for bad machinery.
Okay.
Back and forth.
Machinery? Oh, so you doing some underground?
Yes, sir.
Okay. All right. So that's the biggest thing, just keeping your head on the swivel, huh?
Yes, sir.
Okay. All right. And in doing that, you wear the proper PPE, right, so they can see you?
Yes, sir.
Correct? Okay. All right. about your job, James?
Right now, we're really just digging
Okay.
in we got a 8 foot by 6 foot by 4 foot deep hole.
How big?
Yeah, for our new feeders going in. They're getting ready to bore sometime this week, I think. Not for sure, boring into the building.
Okay.
We had to dig out a big hole.
Does it have to be, excuse me, protected in any way as far as,
Yes.
is that big?
Yes, we got barricades.
Barricades, okay, we got barricades, but inside of the hole, is there any threat of it collapsing or anything? Is it that big?
No.
How big did you say it was?
It's 8 foot by 6 foot by 4 foot deep.
4 foot deep, oh, it's 4 foot deep, okay. So, the biggest thing would be barricades around it, keeping everybody from
Yes.
falling in. Okay. That's about it, as far as anything different.
Yes.
Your job site?
It was very hard. We had to cut out old footer in there.
Oh, really?
And yeah, we had Dixie come out, and that was a very big project right there.
I bet it was.
Cut up all the slab and then cut up the footer that was underneath it. The footer was 1 foot wide by 2 foot deep.
Wow. Okay. All right. How'd y'all get that up? Did you, oh, Dixie did?
Yeah, because they ended up using their saw and cutting as much as they could, and they ended up having a jackhammer and stuff. We helped them clean up and stuff, but
Okay.
it was a 10-hour process.
Really?
Yes.
Okay. All right. Okay. All right, so that's safety. Anything else on safety? Module 1, Section 2 homework. Let's go over these together and see what we can come up with together. So, how about number 1? Somebody got number 1? Timber? You don't have it? Well, you're gonna read them anyway. Go ahead and do number 1, James.
Tamper-resistant receptacle prevent foreign objects from coming into contact with energized components inside the receptacle.
All right, tamper-resistant receptacle. Anybody ever put any in? Huh? Where have you put any in? Have you put any in? Tamper-resistant? Where?
Down at New Horizon.
Where?
New Horizon?
Garages?
No, New Horizon.
Oh, New Horizon. And what is New Horizon?
That patient.
Oh, okay, yeah, patient. So here's one, here's an example one. So you kind of see if you look in there, you can see, now what makes this, what makes it is tamper resistant. Of course, you can't stick anything in here. The only way you can make it function is when something is inserted into the ground, then it opens these up. So y'all take a look at this. It's just a 15 amp tamper. Matter of fact, if you look here on here, somewhere on here is stamped TR, tamper resistant. So this is just a standard, nothing fancy about it. Residential required in a lot of residential places as far as the code is concerned, but we're talking about hospitals. Why do you think you want tamper resistant, or sometimes required in hospital situations or healthcare facilities? Again, because you'd have children, right? I mean, that's the purpose of a tamper-resistant receptacle. So, if you look there, tamper-resistant prevent foreign objects from coming into contact with energized components inside the receptacle. What would be an example of a foreign object?
Butter knife.
Yeah, your knife. Okay, which I'm gonna cut you with, because you didn't do homework. A knife or a fork, or a paper clip. Anything to get their hand on, they're gonna stick in a hole, right? So that's a tamper resistant. Okay, tamper resistant. Now these next two are code section, and we'll look at these in a little bit. But let's look at number 2. Read number 2.
NEC section 517.19B.
Well, you knew that one. But that ain't right. But that's okay. Go ahead. You on number 2 or 3?
2.
2? Okay, go ahead.
Bed located to be supplied with at least 2 branch circuits.
I got 517 18A. Okay, the next one is actually 19B. So number 2 is actually 18A. 517 18A, at least 2 branch circuits. Why do you think 2 branch circuits? Let's just talk about that. Why do you think 2 in a hospital? Would you want everything on 1 circuit?
No, so you can have everything
Yeah.
plugged in.
And typically what you have 1 normal and 1 emergency is what you have as far as 2 branch circuits. So it just makes sense. You wouldn't want everything plugged on 1 circuit. At least if you had 2 circuits, something goes wrong with one, you can plug everything else into the other right quick, right? Kind of a redundant thing. Number 3. James?
NEC section 517-19B1 requires that each patient bed location in a critical care space be provided with a minimum of 14 receptacles.
14 receptacles. Critical care. A lot going to be plugged in there, isn't there? 14 receptacles. That's a lot. Okay. 4, Cameron?
NEC 517.19A require that every patient bed location in critical care space should be supplied at least connected to normal system.
That needs to be split by at least 2 branch circuits. 2 branch circuits. Is that what you got, James?
Yes, sir.
2 branch circuits. Okay, kind of repeat this. 517-19, 2 branch circuits. Number 5.
The grounding conductor must be sized in accordance with NEC table 250.122 and installed in metal raceway with branch circuits conductors supplying these receptacle or fixed electrical equipment.
Yeah. So 250, 122, there's 3 tables in 250, but for this here, and we'll take a look at that in a minute. But 250, 122 is how we size that. And one biggest thing I want to point out to you is in a metal raceway. Okay, in a metal raceway. Because what's going to happen is we're going to find out that metal raceway has to be grounded independently of the other ground, a redundant ground. There has to be 2 grounds. We find that out. So that's the reason, because they want your whole raceway to be grounded. Okay. Number 6, the patient what?
Head wall.
Yeah, no, you good. Head wall columns supplies both oxygen line and electrical power. You got your bed and you got a column there. If you've been in a hospital and there's just columns, some of them may be horizontal and some of them may be vertical. Either way, most of them I've seen probably horizontal. But you got oxygen lines you plug into, and you got power that you actually plug into. And there's that's called a head wall column. Okay, a head wall column. And I say it can either be vertical or horizontal. You've probably seen both in a hospital. Number 7.
Luminaires more than 7.5 feet above the floor and switches located outside the patient facility are not required to be grounded using grounding conductors.
Yeah, not required to have that redundant ground. If it's above 7.5 feet, that light right there above 7.5 feet? Yeah. Is that switch back there above 7.5 feet? No. So therefore, this light, can it be not grounded like this sentence says? What do you think?
Yes.
I'd say no. Because that switch is part of, now what it says, if you read the actual code interpretation, let's read that again. The switch is located outside of the patient's vicinity.
Okay.
That's what it says. Now that switch, I guess, like you walk into a patient room, you got your door coming in, you got your switch, and you probably come down and you're gonna have a bed. If he'd have to get, I say in my interpretation, he'd have to get up out of that bed and go get to that switch that's not in the vicinity. But my thinking was you better ask the inspector, because he might interpret in the vicinity as in the room. It's a local, so I wouldn't, this light does not have to be, but if it's on a switch, then you better make sure that that switch doesn't have to be. In other words, you have to ask the inspector. Now, if that switch was outside the door, I'd say it's not in the vicinity. But how many are going to put switches on the outside of the door? You're not going to do it. So it's more of a code interpretation. But if it were not, then these would not have to be. But the switch is what really kind of puts things into question. Okay. Number 8.
Quit.
There you go. You got it. Quit potential.
Yeah, ground plane is a mass of conductive material that, when bundled together, provides a low impedance
Impedance.
to current flow over a wide range of frequencies.
Yeah, and we're going to see where that comes into play here when we get into the book. You'll see that there. That's a big, long word. You probably don't really need to know the meaning of it, but it is in there. The definition is actually in your book. Okay, so we'll be taking a look at that. Number 9.
Blank as in internal insulated ground wire that is acceptable for use in patient care spaces.
Yeah, inpatient care. So that is hospital grade AC cable. Hospital grade AC cable. Has an internal insulated ground wire that's acceptable for use in inpatient care spaces. And number 10 is talking about number 9. The above cable in question number 9 is identified by what?
Green metal sheet.
A green metal sheet. So the MC cable that you see, it has a green metal sheet on it. Here you go, let me have that receptacle back. Okay, it's a green metal sheet, and it makes it identifiable. Devices in a hospital should be mounted so they are what?
Easy to use.
Easy to use. One of the rules, I think, in the book, how do y'all, typically on a receptacle, what do you mount? Typical receptacle in here, how high do you think it is?
18.
18 centimeters. Hospital, I think it's a little different. I think we'll find out that hospital is 24. Why do you think 24 instead of 18? So you ain't got to bend over quite as far, right? Hospital, you got patients, you got older people. I mean, it doesn't sound like a lot, but to plug in something here versus here,
Yeah.
that's different. It gets a little easier, doesn't it? Higher up you go. 26 inches makes a big difference. To go from here to here. I mean, you got to bend over a good bit the other extra 6 inches, even for a taller guy like myself. So that makes a little difference. So 24 inches, I think, is what we're going to see. Number 12.
Blank are used where separation of the device ground and the building ground is desired.
Can you help him out, James?
Hospital grade receptacle.
Sure. How about isolated ground receptacle? Isolated ground receptacle.
Oh, okay, I see it now. It's
Yeah.
right there on page 11.
Isolated ground receptacles. Let me turn to the next page. Yeah. Isolated ground receptacles are used for separation of device ground, because that's what you think about. Separating, you're doing what? You're isolating it. All right, so here's an isolated ground receptacle. Okay, and you can kind of see here. Let's see what's happening here. Okay, if you'll look, as far as the isolated ground receptacle, you can see here. There's the what are we trying to do with an isolated ground receptacle? You're isolating this ground. In other words, you're typically going to pull 2 grounds, aren't you? You're going to pull one for the device, and you're going to pull one, that goes to the box, is what you're going to do. In other words, you're not going to connect like on a typical receptacle, when you put these in, you got a 4-inch square box, you got a pigtail. What do?
You tap them together.
You tap them together, and you do what? You connect it to here. An isolated ground receptacle, what are you going to do? That pigtail in there is not going to be connected. Okay. You're going to have 2 different grounds. One is just for the receptacle, and the other one would be the grounding as far as the system is concerned. And really, there's not two grounds on it. Again, that's why. The designation, as far as the marking, is just the triangle with a ground, a green triangle. At least this is the way this one is marked. I think most of them are marked that way. Most of them are orange. It doesn't have to be orange. Matter of fact, if it's not orange, this triangle is usually orange triangle, which will tell you that it's isolated ground. Okay. But other than that, I think it may be actually be written on here. Let me see what it is. Let me get my glasses. No, it's not. Okay. No. But you would know that it's isolated. Yeah, it is isolated ground. Right there on the top, stamped on there. Matter of fact, it's stamped on the top and the bottom. On the top. What's the difference between, just by looking at it, what's the difference between these two receptacles? Other than one's isolated and one's tamper-proof. What else is different about these two?
Green dot
Well, other than the green dot
and color.
and the color. What else is different about it?
You got,
It's got a sideways slot, doesn't it? What does the sideways slot represent?
low voltage.
Nope. Any idea what the sideways slot represents? The horizontal slot. Let's call it what it is. The horizontal slot in each one. What does that represent? Question for next week. Tell me what that horizontal means. Write that down. Question for next week. Tell me what the horizontal slot in a receptacle is versus this one right here. This one here has what? Just two vertical, doesn't it? I want to know why this receptacle has a horizontal. It has nothing to do with being isolated. It has nothing to do with being orange. It has nothing to do with anything like that. It's just a difference. This one could have had a horizontal slot. It could have been tamper-proof and had a horizontal slot. Tell me why. Tell me what that horizontal means by next week. Okay. All right. What are we? Number 13. Number 13.
Session blank require that equipment bonding jumper no smaller than a 10 off be used connected to the grounding terminal, all grounding type receptacles of a patient head wall to the patient grounding point provided.
Okay. Equipment bonding jumper no smaller than a number 10 to be used to connect the grounding terminal of all grounding type receptacle at the patient head wall to the patient grounding point if provided. That's a pigtail. Most pigtails y'all put in are number 12, aren't they? So there's a little bit of a difference in a healthcare facility. What's the section code, James? You know?
517.19D.
19D. 517.19D. So that's a little bit of different than what you're normally used to doing every day. All right. Number 14.
Hospital grade receptacles are listed as suited for use in healthcare facilities.
Yeah. Hospital grade receptacles are listed as suited for use in what? Use in what? Sorry.
Healthcare facilities.
Healthcare facilities. All right. Any idea what color dot is usually on a hospital grade receptacle?
Green.
Green. Okay. Hospital grade receptacle. Do they have to be red?
No.
No. They do not have to be red, but they do have to have the green dot. Now, I think it's very good practice for a hospital grade receptacle to be red, because that tells me what? It's pretty important. Red receptacle. You just go in and see them installed every day. But the key here is the green dot. Hospital grade receptacle. There's really nothing other than the fact it's probably more sturdily built. Now, there's nothing different about the wiring. You got the ground. There's nothing different about any type of the wiring. It's just more substantial. It's it's more meatier. It does have the green dot. Again, this one has the horizontal. So you put your grounds up or ground down?
Grounds up.
Ground up? Okay. Yeah. Why ground up?
something falls and hits it.
Yeah, hitting on what? Hitting on the ground, isn't it? It looks upside down, personally speaking, but I think it's the way to do it, because it prevents accidents of something falling on some blades. If it's not, don't be Googling that, James. Because if it falls on the blades, you know, if it's the ground up, then it's gonna fall on the ground and not the two blades, right? Okay. Right, I see what you're doing right there. But as far as the receptacle, it's not any different. It is marked hospital, okay, hospital grade, stamped on the, what is this called? What is this called right here?
Ears,
Huh?
ears.
No, what's this called right here? This right here. This thing that goes, really, if you look, you gotta look behind it to see. What's this thing that goes back behind, it goes from here to here, and what's that called? Any idea?
A bonding jumper?
Nope.
Base.
Nope. Y'all wanna find that out too? What's this called? This piece of metal that includes the ears, okay? That includes the ears and this piece of metal right here. You see it's all one piece, right? It's all one, why is it all one piece? And what's it connected to? It's the ground. So you're grounding all that, right? All that metal. What is that metal called? What's that called? Find that out for me. Okay. Number 15. One of the most dangerous situations is when a patient has an external direct what?
Conductive path.
Yeah. Conductive path. Okay. One of the most dangerous situations when a patient has an external direct conductive path to the heart, such as a cardiac catheter. Okay. What do we know will happen? Then we get electrocuted, which means what? It has to be properly grounded. We don't want him to be the ground, do we? If it is, that's where past the ground's going to go. Because guess what your body's made up of, mostly?
Water.
Yeah, it ain't fat. Okay, it's water. Most of your body's made up of water. And because the water's what? Is it a good conductor of electricity?
No.
Oh yeah, it is.
Well,
Yeah, it's
really good.
It's an easy conductor of electricity, very easy, because man, it just takes off on it. Okay, and so because of that, you know, our bodies are susceptible to being, you know, for us. And the first thing it's going to do is go to your heart. You know, that's probably where it's going to go. So we don't want that to happen in a hospital because we don't want to get sued by doing something wrong. Number 16, special grounding requirements are required in blank procedure location C NEC 517.20. What kind of locations? Wet. Special grounding requirements. I mean, that's pretty much anywhere, right? Anywhere you got a wet location, you have a special grounding, don't y'all agree? And what are you probably going to have in a wet location?
Water.
What kind of receptacle? What kind of receptacle?
GFI.
What is a GFI? What does GFI stand for?
Ground fault, current.
Ground fault what?
Ground fault, current, and,
GFCI, ground fault circuit interrupter, right? GFI would just be ground fault interrupting. Okay. So here is receptacle, hospital grade or no?
yes,
Yeah. Why? Green dot. Is it ground fault?
yes.
It is ground fault. So this is probably pretty expensive. It is ground fault. It has the test and the reset button. Spec grade is written on here. We know that it's ground fault. One of the keys to hooking up a ground fault is making sure that you know on the back there's a what?
Line and a load.
A line and a load. Where's your incoming going to hook to?
Line,
Line. What's your out going to hook to?
line.
Do we wanna get them mixed up? No,
You always leave that piece of paper right there,
that's right.
on there until after you.
Till after you're done, right? Till after you're done. Don't pull it off till after you're done. Okay? And this is just a ground fault circuit interrupter, ground fault. And you could actually do the same thing with a breaker, couldn't you? But this is a cheaper way to do it. And you can also, once you do this, you can go downstream and put other receptacles on this ground fault, couldn't you? Okay. This one here's one that stabs in the back. Ground fault, don't pull this off because I got to give it back. I just borrowed it. Hospital grade, ground up. Again with the horizontal thing on there. Okay. That's something. So there's a ground fault, hospital grade ground fault receptacle. And there's instructions. You know, typically ground fault comes with its own plate, don't it? Because don't throw those away, don't throw the box away. If you don't, you got to go buy more plates. But now there are going to be times when that, especially in a hospital probably, you're probably going to not use that nylon plate, are you? We may be getting to a question in a minute that talks about metal plates. Let's just see. Number 17.
Branch circuits serving only special purpose receptacles or equipment in critical care spaces may be served by other panel boards.
Yeah, and we'll get into the special purpose receptacles may be served by other panel boards. We'll talk about those in a little bit, what those situations may be. But for now, just know, there are some places in critical care where you may have a special purpose outlet receptacle. Number 18, read it, Cameron.
NEC pertaining to grounding of receptacles and fits electrical equipment in patient care spaces.
Okay. You got it, James?
517.13.
Yeah, 517.13. Here's what I was talking about a minute ago. Blank faceplates may be connected to the equipment ground conductor by means of metal mounting screws securing the faceplates to a grounded outlet box or grounded wiring device. So notice the word grounded and everything. So your grounding conductor, and everything is grounded. So what kind of faceplate do you think they're talking about?
Metal.
Metal. Metal faceplate, does it have to be grounded? Absolutely. It needs to be, doesn't it? It's part of the system, isn't it? Once it screws into that outlet, it becomes part of the system. But you're screwing that screw for that outlet into that outlet, aren't you? Okay, and number 20, type blank and blank cable must have healthcare facility rating and be clearly marked as such and terminated by using listed fittings.
MI and MC.
MI and MC, okay? And most of the time we're going to install what? MC cable, aren't we?
Yes.
I'm not sure I've ever put any MI cable in. Mineral insulated, I think is what it is. Okay. MC cable is typically what we use. Okay, all right. And put all these back together in their boxes. All right, everybody got that then? 5G receptacle. All right. So enough of that. I want to try to find something. Bear with me just a second. I'm going to try to find something online for us to take a look at. Bear with me just a second, and we'll come back to this. Well, I tell you what, we'll go ahead and, well, no, I'm going to go ahead and try to find it. Yeah, I ain't going to worry about it. I may try to find it later. So we're on page, just to let you know while we're loading up here. Okay. We're on page 11, aren't we? We're on page 11. and we're gonna talk about devices used in healthcare facilities. Okay. Where do you think the head wall is in this picture?
Above the bed.
Yeah, right there above the bed. What's all on that head wall right there? I mean, what do you see? I mean, just kind of looking at it, what do you see?
A switch.
A switch, okay. What else you see? Receptacles, some data outlets, looks like a speaker, a call of some sort, doesn't it? Some places to plug in, probably some things like oxygen or gas or whatever it happens to be, isn't there? Probably a switch right there in the middle. I don't know what that one thing is, it looks like some kind of monitor, doesn't it? But notice what? There's a what? There's a bunch of them, aren't they? Okay. And also notice that the other outlets that are installed are what? They're up high, aren't they? Easy to get to. And I think that would be typical in a hospital. Probably even minimum would be 24, but higher than. Okay. So we'll be taking a look at that. On page 11, matter of fact, let's look at our next clip here. Okay. Here's what we're trying to accomplish out of just section 2. Paying attention. Okay. Section 2. If you look there, hospital, describe the operation and application of hospital grade receptacles, and we're going to take a look at those in a minute. Identify the receptacles for general care, that's category 2, because last week category 2 was what? Y'all remember? What was the example of a category 2 space? Nursing home? Is that a category 2?
Limited care.
Limited care? Okay. Nursing home? Something like that? Okay. They're not quite as stringent, is it? Well, category 1 is like C there, isn't it? Identify the receptacle requirement for what? Category 1 is like critical care, isn't it? Okay. All right. Remember we looked at those last week. And identify the grounding requirements for receptacles and fixed electrical equipment. You know, everything's got to be grounded in a hospital, so we need to really take a look at that. Okay. Number 2 here. So section 2, section 2.00, as we're going over it, let's look at page 11 and some things that we see here on page 11 under 2.00. If we read here what's telling us, devices in an emergency power system must be color-coded and labeled to make them easy. Look at what they've done in this picture. What have they done? What do you see done here in this picture? You see the boxes, aren't they? They're painted, aren't they? Like you may have some red, that's probably the hospital grade, isn't it? You may have blue, that may be like data or something. You may have a green one, you know, somewhere. You know, there's not one. To me, that would have been like a, you know, MC. You got some red ones up there. Of course, the other pipe in there, there's some gas piping in there, isn't there? What's one of the things that's going to have to happen with this installation? Just looking at it. Just throw it in there? You working around anybody else? Yeah. Look at all that gas piping in there and other things. Look at all the braces and brackets that's got to be put in. Okay? So, is configuration and how we're going to do this important? Yes. Yeah. It's a pretty complicated little mess right here. All the braces and brackets and the height, different heights. I see at least 1, 2, 3, 4, 5 different heights, don't y'all? From stuff, 5 different heights. And you know what? Actually, color coding, it says it here, it's easier, less expensive, and avoids. You just taking your paint and you just color coding this stuff as you put it up. And if a label falls off or something, then we know what it is. You know, versus if it was painted red, we know that it's, I don't know in this instance, but if I was doing this, it'd probably mean generator or emergency backup power, probably red. Okay. All right. So you get, and that's just your own system. There's nothing specific about which color you have to paint it. Just know that when you're doing it, if it is a certain color, whatever your company comes up with, you make up the rules and you put it in accordingly. So, looking on page 11, it says color coding. It talks about that in the first paragraph. figure 6 is, that's what we're looking at, shows that right there. Second paragraph, we don't want to go over that. Devices in the hospital should be mounted so they're what?
Easy to use.
Easy to use. And it says it there because a large number of patients spend time where? In wheelchairs, don't they? Particular attention should be given to these requirements. And so because of that, all receptacles should be mounted how high? 24 inches. But you also need to refer to the drawings. Because, are any of these outlets 24 inches? Well, we don't know. Probably those two down at the bottom are, aren't they? But all the rest of them are what? They're higher, aren't they? Okay. If you go back to that head wall situation earlier, that's not 24 inches, that's higher than 24. So you're going to have situations where you're going to be more than 24 more often than not. 2.1.0 talks about hospital grade receptacles. Yeah, I've showed you one of those. Let's look at Article 517. Let's just turn to Article 517. And it is healthcare facilities. But we'll be referring to this. Matter of fact, 517.13 talks about grounding of receptacles. But we'll be looking, just keep your code book open to 517, so as we get to these different things, we can kind of look at them. But Article 517 says healthcare facilities, hospitals, nursing homes, limited care facilities, clinics, medical and dental offices, ambulatory care centers, where permanent removal. We got to have, we're going by 517, healthcare facilities. Hospital grade receptacles are often marked with a green dot on the outer face of the receptacle. We saw that tonight, didn't we? Here's the thing, as you look here, they meet nationally recognized testing laboratory criteria. You know, that hospital grade receptacle I showed you, money-wise, is probably 15 times more expensive than this normal duplex outlet. 15 times. Pretty expensive, isn't it? So you don't go taking those home and deciding you want to put a red outlet in your bedroom because you got red paint. You know, don't go stealing those. There's a reason there's nothing different about them other than the fact that they meet the standard of say. What happens a lot of times, like on an outlet that you buy to put in a house? What have you ever had one just kind of fall apart? I have. Okay. So they're made sturdier. They're made to where the little, the way that they're constructed, they're not going, the ground, and I ain't going to call it what it is, the ground part on the back of it is not going to come loose. Whereas, you know, on this 50-cent receptacle, they might do that, mightn't they? Because, I mean, you kind of look at one, you kind of pick it up and tell what? It ain't what? It's a little heavier, isn't it? That hospital grade receptacle is, and this, even than this tamper-proof. There's really nothing special about it other than little things in there. But man, you can really tell the difference in the construction between these two. Even the type of plastic that's used. Okay, a harder plastic, a thicker plastic, a heavier plastic. Okay, so we get into more construction. That's a hospital grade receptacle. And you see there, it's got to meet certain mechanical strength. What do we not want to happen in a hospital grade receptacle? We don't. I would say that probably more than likely, where we insert the connection, do you think is probably firmer and more rigid in a hospital grade receptacle? I'd say that it probably is, because what you don't want to happen? The cord to fall out, right? Anybody want your respirator to fall out of the receptacle? No. Power feeding that. And so that's probably one of the things that I'm sure that they test and see, because, I mean, you know, at home, especially if you got an older outlet, it starts getting loose, doesn't it? Okay, for multiple use. So hospital grade outlet kind of keeps all that needed in medical environment to ensure that equipment plugs fit tightly into the receptacles. You know, I don't have anything to plug in with me to do it, but I'll guarantee you if we took this receptacle and this hospital grade receptacle, I bet you would find that it's harder to plug something in that is hospital grade receptacle than into a normal outlet. If I had something, well, hold on, I do. Let's check and see. Let's test our theory. Let's check this bad boy and see. So we've got a typical outlet, and let's see what can I unplug. Thing will hurt me. I'm getting off camera, but I think let's look. Let's take a look here. Cameron, come over here, Jane. Jane, get off your phone. You ain't on the computer, are you?
No, I moved now.
Alright, so, let's try, I'm gonna try it and I'm gonna let y'all try it. If I'm plugging this in, of course it probably ain't gonna be either way. I really just wanna see if I can physically tell a difference. Probably won't be able to, but all these are new. I don't know. Yeah, I can tell a difference. I can tell a difference. I can definitely tell a difference in how it slides in. To me, try this and see if you kind of feel a difference. I can, and just the way it almost like, the hospital grade to me is almost more like spongy, almost like it kind of like sucks it in. Or this here is just more rigid. It's not as flexible. You know what I'm saying? That's kind of the way I feel it. Check it and see. I'll check it and then plug it in when you get done. Check this too. See what you think. You ain't found out what that horizontal line means yet, Jim?
No,
No.
I think it's ground.
No.
Let's see. I know it. My mind is blank.
That's all right. Don't be fretting over it.
And then as soon as I see it, I'm gonna be like, duh.
Yeah, don't be fretting over it tonight. It ain't a big deal. Just a challenge, just something to think about. I can tell the difference, I think, when I plugged it into that red one versus that normal one. It just kind of like it, you know, like it's a snugger fit or something, you know what I mean?
It almost like it just kind of squeezes in there.
Squeezes it in there. You can plug that back in when you get done. I'm gonna keep talking while you're doing that. The next thing is isolated ground receptacles. We talked about those, isolated ground. They're used where it's separation of the device ground and the building ground. And so you're gonna separate the device ground from your conduit ground, aren't you? Okay. Usually there's an isolated ground bar. Matter of fact, if there's not an isolated ground bar in your receptacle, in your panel, then why are you isolating that ground? Anyway, so, because you need an isolated ground bar in the panel to actually make it an isolated ground. Because if you send them back both to the same bar, then is it really isolated? That's just kind of, but a lot of times you don't see that. They're normally used for digital electronic equipment and computers. Matter of fact, that's where you see it a lot of times in retail stores and things like that. Is in a computer or hooked up digital process equipment. They prevent transient voltages on the ground system from causing malfunctions in digital circuits. Isolated ground receptacles shall not be installed in a patient care vanity, okay, for NEC 51716A, okay. You cannot put an isolated ground receptacle in a vanity in a patient care facility. So that's kind of interesting to know. And that's 51716A, if you were looking at our code book. 51716A. Is that what it said? Yeah, 16A. And an isolated ground receptacle shall not be installed within a patient care vicinity. What did it say? Vicinity? Patient care vicinity. That says vanity, doesn't it? But the actual code book, I think that's an error right there. The actual code book says vicinity, not vanity. Okay? So you need to change that word from vanity to vicinity. Vicinity. So that last sentence is from vanity to vicinity. Vicinity meaning what? Something what? He can lay in his bed and reach, right? Okay. Tamper resistant receptacles, we talked about those.
prevent foreign objects, okay? I think that's enough about that. We can kind of see where they must be used. Would this make sense in a psychiatric department?
Yeah.
Yeah. Because what's somebody gonna try to do?
Trying to put something in there.
Kill themselves maybe? And they go, I can do this with this receptacle, couldn't I? Okay, hold on to it. So, psychiatric facility, we would want tamper-resistant receptacles. General care, 2.2.0 spaces. We look here, 517.18a, let's take a look at that in our code book. 517.18a, if you see there, each patient bed location shall be supplied with how many branch circuits?
2.
One from
Critical.
all the what? Yeah, critical branch. And what was critical branch? We discussed it earlier, last week, didn't we? And one from the normal. If you go back to section 1, let's go back to section 1, let's go back to where we was at last week. And we looking on page 3, critical branch was the red one, wasn't it? On page 3, you see you had 3 different types. Equipment branch, critical branch, and life safety branch. Okay? And so that critical, we see it here used now in the code book, the critical branch would be, that's one of the circuits would be from critical branch, and the other one would be from a normal system. Okay, makes sense, that's why we would have 2. Okay, so that's 517.18a, and I think that's what we're really, if you look, matter of fact, there's a little code change in the gray there. The electrical receptacles are the cover plate for the electrical receptacle supply from the critical branch shall have a distinctive color or marking, so they are to be readily identifiable and shall be indicate the panel board and branch circuit. It doesn't say what color, does it? It just says what? It just says a color. You designate what that happens to be. Now, odds are I'm probably going to put it red, aren't you? You know, I'm just thinking, because I can buy this red receptacle and it's a hospital grade receptacle. Okay. But it doesn't have to be. It doesn't go into detail of saying what color it has to be. It just says it has to be a color, a distinguishable color difference. So you'll know normal from critical care, right? All right. Branch circuits, the next sentence there, branch circuits serving patient bed locations shall not be a part of a multi-wire branch circuit. In other words, they can't share neutrals. Okay. All right. I think we've looked at these. Yeah, here's where we are here. 517, every patient must be supplied with at least 2 branch circuit, one for normal and one for the emergency. Must be supplied each, matter of fact, if you look here, if you see here, the next bullet point there, and what we're looking at now, as far as this part, we see here that each patient bed location must be supplied with a minimum of 4 receptacles. Okay. What is a receptacle? Is that a duplex? If you look at that picture there, you see that picture there? The receptacles right there above bed. You see that there? How many receptacles are there? 4. Because each what? Each place you plug into is a receptacle, isn't it? Because what is that? What is each one of those called? What's that called?
Duplex.
A duplex. A duplex means what?
2.
2. Okay? So that's 2 receptacles. That's 2 receptacles. That's where you get 2 duplex is what?
Quad.
Yeah, in which a quad means what?
4.
4. Okay. So that's where you get the number from, and that's why you see that in that picture. Not 4 duplex required, but 4 receptacles required. All right, if we're looking, well, let's just finish up. Let's kind of look down through 2.0. Look at some bullet points there on page 13. Let's read a couple of these here. I want to bring these to your attention. Look at the first bullet point. Branch circuit serving only special purpose. I think this was one of our questions, wasn't it? Let's look at this. Special purpose outlets. So let's see what a special, I think we had to question, what was a special purpose outlet? What would in that room, what would the special purpose outlet be? Well, here it tells us, such as what?
portable or X-way outlet?
Yeah, a portable X-ray outlet, something they're gonna bring in and out, okay? Not gonna be plugged into the stuff that's on the bed, is it? So it's a special purpose outlets, do not have to be served from the same distribution panel or panel boards. Okay, can be something different. Patient beds located in clinics, and if you read the rest of those there, the requirements NEC 51710B are exempt from this requirement, okay? Let's see what 51017B2 says. Turn to that and see what that says. 51710B2. 51710 just talks about wiring and protection. And then its applicability, part 2 shall apply to patient care space or other healthcare facilities, but here's what's not covered. Part 2 shall not apply to the following: business offices, corridors, waiting rooms, and the like of clinics, medical and dental offices, and because what's not going to be in those areas?
Wheelchair,
What person is not going to be in those areas?
patient.
Patients. Okay, so you don't have to. And would you have to put medical MC in the business office of a hospital?
No.
That's what that's saying. No, you wouldn't. You wouldn't have to follow these guidelines in the offices or the conference room or the training room or the hallway or the break room or, you know. The only place we're doing it is where what? In an exam room or a room where what? A patient can be hooked to a piece of equipment. Okay, that's what that's saying. Okay. All right. Looking at 2.3.0 here, critical care, space 1. We look here at 51719B1. Matter of fact, let's look in the code together. 51719B1. Each patient and bed location shall be provided with a minimum of how many outlets?
14.
Yeah. And listen to this. Look at what the rest of this reads. And at least one of which shall be connected to either of the following: the normal system and a critical branch circuit supplied by a different transfer switch than the receptacle at the same patient location. 2 circuits, one for normal, and just kind of backing itself up. So if you look here on what we got here, up here, okay, we've got what? Critical branch receptacles. And I'm just gonna try to get us on through this tonight, guys, instead of taking a break. Y'all good with that? As long as you stay awake. If you like, you're gonna fall asleep when you take a break.
Not that.
Then I'm gonna prolong the class. Stay awake. Okay. All right. So, critical branch, what is that coming from?
Emergency.
Emergency, right? Critical branch. Normal circuits, coming from what?
Normal.
It's a normal thing, okay? And we have what? Patient bed location, another patient bed. We've got what?
Another emergency.
Yeah. All right. Supply with at least 2 branch circuits. Have we done that in this picture? One for normal, one for emergency. Each patient bed location must be supplied with a minimum of how many receptacles?
14.
It says 6. See, now this is not critical care. Oh, it says critical care 1 spaces. Okay. All right. Let's read where we get into that right there. 14 receptacles. Let's see, guys. Let's see that at. Yeah. Figure that. I'm looking. Where are we seeing 6 outlets at? I'm missing it somewhere. Critical care space. I'm with you. When I first read that, each patient bed locations, critical care area, and then, but this one here says 6. Each patient bed,
I'm gonna kind of read, each patient bed location must be supplied with a minimum of 6 receptacles. And I'm looking at the code, and it says each patient bed location shall be provided 14 receptacles. Well, they go from 14 to 6. Yeah. Well, that's correct. Are y'all finding 6 in here anywhere?
No, that's what I'm looking for.
I'm looking for it too, guys. I'm not seeing it. I'm looking at critical care, and I'm kind of reading. 517.19 requires that every patient be supplied with a 2-branch circuit, one or more. At least 1 branch circuit. All branch circuits are normal. Critical must be receptacle. We got to be labeled. 19B1 requires that each patient bed. We just read that. 14. At least one of which we just seen that. NEC operating rooms, you got to have 36 receptacles, which 12 that are connected to normal. There may be a single. All receptacles must be listed hospital grade. Let's see what it says here. A typical receptacle configuration in figure 9, which is what we're looking at. The normal circuits may supply from L1, we saw that. The critical care circuits may supply from EML1 or EML2, we saw that. However, the critical branch circuit for a patient bed cannot supply a critical branch circuit for a patient bed. And that's why you see there, they're going from what, 2 different panels, aren't they? But they can't be, we see that there. The required power level for bedside is typically 90 volt amps for single outlets. Under the following recommendation are made for bedside station. You know, hospital grade permissible, no less than 2 new plates on each side of the patient bed. Outlets must be protected, each from I think they're wrong. I don't know why I don't know how they come up with 6. Y'all seeing 6 anywhere? I'm not. I'm seeing what? 14, aren't y'all?
Yeah.
Okay.
Yeah, I don't went all the way.
Yeah, I have too, and I don't see 6 anywhere. Okay. All right. 2.4.0 grounding receptacles and fixed equipment. So turn to 517.13 in your code book. We look at the NEC, wiring methods. A, all branch circuits serving patient shall be provided with a what? Tell me, somebody read that, 5713, must be provided with a what?
Effective ground fault current path.
Yeah, keep reading.
By installation in a metal raceway system or a cable having a metallic armor or sheath
Yeah.
assembly.
Go ahead and read the rest of it.
The
Yeah.
metal raceway system or metallic cable arm or sheath assembly shall itself qualify as an equipment grounding conductor in accordance with 250.118.
Okay. So what that's saying then is the metal, whether it's the MC cable, because what's happening is in the hospital grade MC cable, you've got an insulated ground and you've got a what? An uninsulated ground. And an uninsulated ground is actually, again, with that it's uninsulated, it is actually not connected to, but it's it's with the sheath is what it's talking there. So really what's happening is whether it's MC cable or whether it's EMT, your ground path is along either that sheath or that raceway, whatever it happens to be. That's why you have the redundant ground in an MC cable like that, because you want your raceway system, and a raceway system in conduit's easy, isn't it? But a raceway system in an MC cable is the sheath, the outside. Now can you just put any old type of connector on the end of that MC cable? No. It has to be a listed, approved connector for that MC cable. Okay, so because that connector too has to be what? Grounded for that path to consist. Okay, so reading on there, so what is redundant grounding? Patient care must have redundant grounding. What does redundant mean? Redundant grounding.
And that the ground and the sheathing.
You're doing it, you're doing it twice. Redundant means you're doing it twice, at least twice, okay? Even though you really only, technically how many times is something really grounded? It's technically grounded one time, right? Because what goes to all the grounds? They all go back to what?
Building steel.
Building steel, the grounding electric. There's only one ground, but what you're trying to ensure with the redundant ground is what? If one comes loose,
The other there to back it up.
the other's there to back it up. Just like emergency power, you may have two generators, right? In a two generator system, you want what? If one doesn't work, one fails, the other one automatically works. Okay? Redundant grounding, that's what that means. We just covered that part. Effective ground fault current path, okay? Effective ground fault current path. What's going to cause something to happen? What is a ground fault? What's happening at a ground fault? Think about it. What is happening at a ground fault?
Faulty ground.
There's a fault. A fault in the line, and what's it going to go to? It's going to go to ground, isn't it? Okay? We want it to go to ground, don't we? We don't want it to sit there on that line voltage, do we? We don't want it to sit there. We want it to go the ground fault. We want it to go to ground, because if it goes to ground, then what it's going to do? It's going to trip the breaker. It's going to trip the ground fault. It's going to do something to make the circuit no longer be energized, right? Am I right in saying that? Okay. And that's what we want to happen. Third bullet point, insulated copper conductor for grounding conductive surfaces or fixed equipment, okay, electrical equipment. So if we look there, that's kind of the bullet points that we're kind of looking at. So if we're looking on, matter of fact, one of the things that it brings out on page 14 and 15, we look on page 15, the grounding conductor. Well, I was going to look at it. Let's go to 215, 122. 250, 122. 250, 122. Now this is one of the tables that we were going to look at earlier. 250, 122. And let's read, I'm going to read that sentence again in the book, and then we're going to look at this table. It says the grounding conductor must be sized in accordance within 5 table 250, 122, and installed in a metal raceway with branch circuit conductors supplying these receptacles or fixed electrical equipment. Well, how do we do that? If you look there in our table 250, 122, minimum size what? What does it say?
That has this.
What minimum size, what does the heading say? Minimum size what? Minimum size, what's the next word? Table 250, 122.
Equipment grounding conductors for
Ah.
grounding raceway equipment.
What was the word? Equipment, right? What is equipment? Whatever it happens to be, whatever it is, right? So it says the table is equipment, minimum size equipment grounding conductors for grounding raceway and equipment. Is that what we're doing with this patient care facility? We're doing what? We're grounding what?
All the equipment.
The raceway, right, Jane? Quit looking for that. I see you on your phone. So we're grounding the raceway, and here's the key. So when we're grounding the raceway, look at how we size the equipment ground. By the size of the wire. How do we size the ground in table 150, 250, 122? How do we size the ground?
By the amp.
Based on the amps of the what? Look at it closely.
Equipment.
Now, not an equipment, but the, read it there at the top. The what? Overcurrent device, which is what? One of two things. Overcurrent devices
Breaker.
are
Fuse.
fuse. So our ground size is directly related to the overcurrent protection device size. And equipment grounding is what we're doing here. We're equipment grounding, because if you look here, what does that say? Insulated copper conductor for grounding conductive surfaces and fixed electrical what? Equipment. And what did we just see in table 25122? What does it say the heading is? Minimum size
Equipment grounding.
equipment grounding. See, that's where we, because here's the thing, guys. Let's say you didn't know. Just put your finger right there. Let's turn back to it. Let's turn back to 25066. Table 25066. Could you use this table to do what we're just trying to do?
No,
Why?
because that's the alternating current system.
That ain't the, that's not the, that's a good answer, but that's not the right answer. Okay. What does the heading of 25066 say?
Grounding electrode.
Grounding electrode. What is the grounding electrode?
Why? The delta.
Grounding electrode's going to have to be ground rotted, going to be built of steel, right? Okay. Does it say anything about equipment? No. As a matter of fact, it doesn't, not even wired. How is it sized? According to what? Look there at your table. How is this grounding size? According to what? The wire size, right? This ground, you know, the under, it's sized according to the, if you read it there, the size of the what? The largest ungrounded service interest conductor or equivalent. So you begin to start to see the difference between the two. All right. Let's go to one more table while we're in grounding. Let's turn over to 250. Let me find it. Give me a specific number. Let's just skip it over. Looking for it. Oh, it was before. No wonder. Give me bear with me just a second. 250.102. What is 102? What's the heading of that say? Remember, read the heading, 250.102.
Bonding, conductors, and jumpers.
Yeah, bonding conductors and jumpers, doesn't it? Okay. Bonding conductors and jumpers. Okay. Bonding jumpers, like a bonding jumper would be like inside of a, probably like inside of a, you know, maybe a gutter, but you'd have a bonding jumper, right? And they're sizing according to what? Wire size, aren't they? So we go back now to our table, which is 251.22, and we see here that of these three tables, this is the only one that goes by amperage or overcurrent device. And we also see this is only one of the three tables. It says that this grounding is for what? Equipment grounding, right? It's for equipment grounding. So that's why we're using that table. A long about way to get there, but you need to understand these three tables and why we use 122 to find that ground wire size. Okay. Just kind of looking at the rest of it, I think we kind of talked about that. On page 16, I think this is interesting. Let's turn to 517.31. 517.31. C3. It talks about mechanical protection for essential electrical systems. It says the wiring for life safety and critical branches shall be mechanically protected. Where installed as branch circuits and patient care spaces, the installation shall comply with what's listed below. And let's look at what C3 actually says. Listed flexible metal raceways and listed metal sheath cables and any of the following were used in listed prefabricated medical head walls and listed office furnishings were fitted into existing walls were accessible. Okay, so we see here the protection has to be they shall be permitted to be used
you know, in those type of facilities, okay? Page 16, James, you give us the answer a minute ago. You know, look there about the middle, equipotential, I think is how you pronounce that. Grounding is one method of grounding and used for sensitive equipment. What do you think a sensitive piece of equipment might be? You might be sitting on one right now, right? A computer? What else do you think might be sensitive? How about a heart catheter? How about you know, something that's going to monitor your breathing, going to monitor your heart, right? You think that's sensitive equipment? I want it to be sensitive, don't y'all? If I'm hooked to it. And you see here, this ground plane is a mass of conducting material that, when bonded together, provides a low impedance to current flow over a wide range of frequencies. In other words, it's not allowing some of these the frequencies that may, you know, to jump onto the ground. You know, you got to the larger the plane, the larger your plane ground is, the more effective it is. I think is what they're trying to say. Okay. If you see here, these ground planes shield adjacent sensitive circuits or equipment, noise fields between their source. You know, it just kind of gets into stuff that we're really not, you don't get into in the field. It would be more of an engineer. Equipment plane structures such as metallic screens or sheet metal under floor tile, the supporting grid or raised floor access. I've seen it like a potential ground, particularly like in a computer room where they don't want static, and you see an equipment that ground is actually connected to the floor. Okay, you see that, you may have run into that before. And I think that's kind of enough on that. We look here on page 16, we kind of see hospital grade. We see a picture of it there. We see the AC cable has an internal insulated ground wire that is accessible for use in patient care facilities. Is identified by what? A green metal sheath. And it's usually, it's actually tagged that way. If you see here, HCF, okay, 90 degrees, plus. If you see, if you actually can read that label, let's see if it's on mine. I don't think it's on here. It's not. Yeah. Okay. All right. So anyway, all right. So let's take a look at our review question on page 17. Hospital grade receptacles often marked with a what?
Green dot.
Green dot. Number 2, which of the following is true with regard to electrical safety in patient care spaces?
14. 14.
Number 2.
Oh, that's on the wrong. My bad.
It's on the board here. Let's read it. Which of the following is true with regard to electrical safety in patient care spaces? A, the possibility of electrical shock can be reduced by reducing the resistance of conductive circuit that includes the patient. B, all branch circuits from the normal system must originate in different panel boards. C, every circuit supplying a patient bed location must be supplied from the emergency system. Or D, this hazard worsens as more equipment is used near a patient, such as in surgical suites and intensive care units. Which one do you think it probably is? Which of the following is true regarding electrical safety in patient care for spaces? A, B, C, or D?
A.
No, I'd say D. I'd say D. Because we are going to have more and more equipment in a room, and when we have more and more equipment, we have more potential, you know, for something to be wrong. You know, for that equipment might to be grounded properly or something. You know what I'm saying? I mean, that equipment could come in. So I think the more equipment we have, the more, you know, the more probability of something actually going wrong can happen. Okay. But I can see A, James, really. I mean, when I first read it, but the answer is D. Every patient bed location in a critical care space must be supplied with at least what? 14. We're going with 14. Matter of fact, 6 isn't even an option. Is it?
No, it's not.
Okay. Sensitive equipment in healthcare facilities can be shielded using a what? What we just talked about, right?
equip potential
Yeah, there you
grounding. Yeah.
I cannot say that word.
Yeah, it wouldn't be white noise. White noise is something you put in a room to keep everybody from hearing your conversations. What we need in our office, everything. We need white noise in our office, by the way. Everybody who's listening to this. All right, so, you good with devices? Everybody good with devices? All right, did I give you your homework sheets for next week, right? I already give you those. Say yes.
Yes, I've already done it.
All right, you've already done it. So, for next week, read sections 3.00 through 3.52. And what are we going to talk about? What does it say there on page 18? What are we talking about? Wiring and healthcare facilities. Okay, wiring and healthcare facilities. And you really just read through the rest of the chapter. And this will finish up healthcare facilities next week. So just kind of let you know what our schedule is. We'll finish that up next week. We'll try to do the review question. If you want to look at the review questions on page 26 and 27, go ahead and look at that. You need to do the review questions in the back on page 25. Do your homework. You didn't do it this week. Page 25, do your homework. Do page 25 and be looking at page 26 and 27, which is review questions. And then I'll try to give you some things to review, because hopefully in 2 weeks we'll have a test on healthcare facilities. So we'll have a lot to go over next week. So let's get here so we can get it over with. So yeah, next week. Okay. I don't know when Christmas break is yet. I have not found that out. I know we've got 4 more weeks before we have to do it. So we're okay for a little while. Remind me next week, guys, I got to make some copies. I need to get y'all to do another one of these forms here next week. I need to bring them to you to do that. So, any questions or comments? We're good for the night? You good? You good? Any questions? All right, y'all good? I'm good. Did you bring me them out? No, go ahead, you did.